Good afternoon, ladies and gentlemen. Very happy to be here today. I hope you're doing fine, and excited with you, hopefully, to tell you a little bit about what we see as the electrifying future, specifically, of course, with KUKA. So what I try to do is I like to give you a little bit an overview. Starting from the motivation, why are we talking about and why are we implementing electromobility? What are the changes that come with e-mobility in terms of lead markets, in terms of players in the field of e-mobility, and the rules that the game is being played by now? And then, of course, e-mobility is on the one side a big challenge because a lot of things change, but on the other side it's also an opportunity to find a new place in this world, in establishing new processes, new markets. So in that sense, it's not only electrifying in the literal sense, but also electrifying in the sense of being exciting and very new, and people are enthusiastic about it. At the end of the presentation, I encourage you to stay with us because at the end of the presentation we'll have a world premiere of a video showing a recently deployed battery production line with our customer Webasto, which gives you a little bit an insight in how we translated these challenges into a modern state-of-the-art line which helps our customers succeed and compete in this interesting market. So, to start with a motivation, the topic here is decarbonization. Everyone is talking about Industry 4.0, so I would like to go back a little bit now and remember Industry 1.0, which happened about 250 years ago in the late 18th century. What happened then was that people discovered that they can build machines and they can power the machines with fossil fuels, with coal. And this was the starting point of an evolution where mankind started to use fossil fuels. Initially this was not so bad, but the speed has massively picked up. And to give you a little bit a picture to illustrate the dimension of this evolution, fossil fuels developed in Earth's history over a period of 150, 200 million years. Mankind has now consumed this fuel to a large extent within a time frame of only 100 years. So translating that into more reasonable proportions, imagine you are collecting fuel for 1 year, and then in the same proportion you are burning all that fuel in a couple of seconds, 10, 20 seconds. So basically we're doing a firework right now where in an instant we're burning what Earth has built over millions of years. So putting it this way, this doesn't look too healthy. What is the impact? Obviously all the stored carbon is turned into carbon dioxide and is going into the air. The concentration of carbon dioxide has an impact on the global temperature, global warming. There's a lot of debate, but when you look at the pictures, at the statistics over the last 1 million years or so, you see the CO2 temperature evolution going up and down a little bit. You have a warm age, an ice age, another warm age, an ice age. And then in the last instant, the curve jumps up by a factor of 2. This is the CO2 that is introduced into the atmosphere by mankind. This is not healthy. We are feeling the effects right now, but even if you think this is not a good reason to rethink the strategy, another good reason is simply all the fuels will eventually be burned. Maybe not in a year, maybe not in 10 years, but it's not a nice gesture when you live in a house to burn all the furniture and maybe even the roof and everything that is made of wood before you die, and then leave the rumble to whoever comes after you. So climate and resources are very good reasons to reconsider the use of fossil fuels. What is the alternative? When you look at the energy consumption of mankind, today this is roughly 150 terawatt hours. It's a very huge number with 17 zeros, so it's big. But compared to the energy coming from the sun to the earth, this is only 1/10 of a million of the energy coming from the sun to the earth. So a natural idea would be to use renewable green energy. That would essentially be, solar energies, photovoltaics, wind energy, water energy, but also maybe wood that regrows, etc. What is the common denominator of all these new energy forms? Well, quite simply, they are produced in the instant and they are turned into electricity. They do not come in a storage package that you can put away. It's coming in the form of electricity. So the natural idea is to use electricity wherever possible, also for cars. Obviously, the sustainability of e-mobility depends on how green is the energy that is used to drive the car. Currently, electricity made on the global average is still 60% made of fossil fuels, but it's possible to reduce that. So e-mobility enables using electricity for a more sustainable mobility. It's a little bit a hen and egg problem per se. Electrical cars do not help. It's the energy that powers them which helps move the problems maybe to the better solution on this planet. So e-mobility is a necessity. Over the last years, the demand for electrical energy storage, lithium batteries used for vehicles, has exponentially grown. Over the last years, actual demand has exceeded the predictions of the year before, consistently over the last few years. It's an exponential growth, and it's here to stay. It's not a hype that will simply go away, because there are very good reasons. It's necessary from a CO2 perspective. It's increasingly enforced and required by law through regulation. Proof has been made that it's possible, which has been questioned, whether it's reasonably possible, already still a couple of years ago, until it has been proven that it does not only work, it's actually fun to drive an electrical car. And last not least, people are doing it. So if we join or not, doesn't change the way things are moving. And everyone, I think, in this year has accepted the fact that this is the way it's going to be. Electromobility is not necessarily a fully electrical, battery-driven car. Electromobility is everything that uses an electrical engine to create mobility. That can be the recuperation of a mild hybrid, where kinematic energy is recovered and then used to accelerate at the next intersection again. It can be a hybrid, it can be a fully electrical car, but also hydrogen fuel cells will use electrical drives and batteries, so they are one flavor of electrical mobility. There will not be one size fits all, but for each application there will be solutions which are ideally suited for that purpose. So postal trucks delivery in the city, ideally suited for electrical vehicles. Long distance trucks, maybe better fuel cells. Something in the middle, maybe some hybrid solution for a time until everything has improved so that storage is even better than it is today. The trend is clear and there is no way back. What has been ignored for some while or not realized to the necessary extent is the massive influence that this evolution has on many things. It's actually a disruption. So there are three topics that change. One change relates to the lead markets. Historically, the individual passenger car was invented in Europe. You know, the well-known names, Daimler, Gottfried Daimler, Carl Benz, Adam Opel, you know, the early pioneers of mobility, they come from Europe. Henry Ford has, you know, translated that in Industrial Revolution #2 in mass production. And until quite recently, the OEM world was a club basically of Europe, North America, and Korea and Japan. Those were the major players. This is now rapidly changing for several reasons. One reason is that CO2 is not a local problem, it's a global problem. Number one. A second reason is that the big growth markets these days are in Asia. So primarily China these days. To give a figure to that, the current expectations are that China alone will use more new cars in 2030 than Europe and the US combined. So China alone is more than Europe and North America together. These are tremendous figures, and there is a strong need to improve climate in China. There are very big cities with quite significant pollution problems. There is a real need. And also, it's a good starting point for the Chinese economy to bet on e-mobility because it's a new playing field and it's easier to gain ground with a new technology rather than fighting with people who have done their job for many, many years before. So lead markets are changing. What else is changing? The players are changing. Why is that? E-mobility is a lot more simple technologically than conventional combustion cars or powertrains. There are fewer parts, an electrical motor, a little bit of electronics, and the battery, and that's essentially it. So the entry threshold to build an electrical car is a lot lower for e-mobility than it was for combustion engines with sophisticated turbochargers, etc. That invites new players to the arena. So there are startups who have a great idea, a little bit of funding, a couple of billions. They buy some experts from established OEM companies and they make their own car. Examples, you know them, Faraday Future, Byton, Lucid, and many, many more. So new players. They have an advantage. They start from a green field. They don't have to worry about transforming what they have already. They custom build directly following the new requirements, which is a significant benefit. The second set of players is spin-offs from academia. In Germany, quite well known in the region of Aachen, there are Street Scooter, Ego, so university spin-offs who have come up with new mobility concepts and car prototypes, so they can do it. Battery manufacturers like BYD, they think, well, I can build the battery, I do that today, but I can also build the car around it because, you know, I master the key technology already. And last not least, also players from other industries are joining the arena, such as consumer electronics companies. An example would be Sony presenting an electrical concept car. Apple is more and more mentioned in the context of cars. And there will be more to follow. One interesting example that was, I think, a year ago, a hot story. The company Dyson, known for ventilation systems and vacuum cleaners, they had the idea, I can handle batteries, I can build electrical motors, I can build vacuum cleaners, I can build a car. So they started out designing a car, and then they stopped. And what was so interesting was the reason they gave for stopping. And the reason was, it's too simple. Everyone can do it. There is no reasonable possibility to differentiate from everyone else to make it a successful business case for them. So the players are changing. What else is changing? The rules are changing. The rules in the game. The value, one game change is the value of the experience and expertise that has accumulated over the last years is rapidly losing value. When you can do an electrical car much simpler, the value of mastering very complex, highly sophisticated turbo engines is not so important anymore. Times are changing. It's a disruption. So in an analogy, 10, 20 years ago, it was very impressive to have an Encyclopedia Britannica on your bookshelf. It's nice to look at, it's nice to hold. It captures the knowledge of the world. Now, it's something that sits on the shelf, because when you really want to know something, you go to the internet, you go to Wikipedia, and then it's up to date and much more comprehensive. It's very likely that the same will happen to powertrains. When there is something much simpler and more convenient and cheaper, why should you bother to use the old, complex and slow processes? Another game changer, another rule that changes is the necessity to look for the environment. When the first cars came up, the fuel was bought in the pharmacy because there were no gas stations, because it was new. But over the last 50, 100 years, it's not a problem. You drive to the gas station, you don't have to worry about it. It's there and you can rely on it. When you go to e-mobility, as a producer of a car, you now also have to think about how can you ensure that the customers can actually charge the car where they want to travel. How can you ensure as a manufacturer for batteries that supplies are secured, because now you have different elements, it's lithium, it's cobalt, whatever, which is a completely different supply chain, so you have to worry about this as well. You have to worry about cell production that creates new dependencies. Oil, the dependence was on the Middle East, Saudi Arabia and neighboring countries initially anyway. And for cells, the dependency evolved from Asian countries such as Korea and China eventually. And it takes a while to realize that and to understand how to best deal with it. So that was the second change. The third change, time constants are changing. In the automotive industry, it was customary to develop a new model like every 8 years, have a facelift after 4 years. So you had a planning security of maybe a decade. This is now changing because the new players, consumer electronics, is entering that market, and a smartphone, a new revision, is being released essentially every year. So the succession of new models and model changes are a lot faster than they used to be. And people and producers need to familiarize with that and learn to deal with this. So time constants are changing, and also business models are changing, because now it's not just the product, the car, the vehicle, but it's really the whole ecosphere with leasing models, with servicing, with ownership of batteries, change of batteries. So it's a whole new business model. So the games are changing. And with these changes, obviously, come technical challenges that need to be addressed. You know, there is a saying, when you're enthusiastic about combustion cars, you have gasoline in your veins. And that may be true in, in a translated sense, but gasoline in the veins does not replace or easily change into electricity in the nerves. Electricity is a different animal. You notice in your personal environments, there are people who can do a great crafts job, but they don't touch electricity because it's different. That problem also exists for established players. So they have to learn how to deal with this new environment and this new technology. So as a conclusion, they need to work with someone who knows how to handle this technology, to have a partner, to find new partnerships, to develop this field together and to grow together in this new technology. There are different processes that become important. Now it's not welding and varnishing and stamping, pressing so much anymore, or machining parts. Now it's more about electrochemistry, about electrical contacting, thermal contacting. So again, different processes, different expertise, different partners are needed. The dynamics are much higher. So you need also production equipment that can go with that speed, that can be adopted, that can be changed, extended, modified, because the horizon of the plannable future is much closer now than it was, a couple of years ago. Dynamics are changing. Another important aspect is safety. Everyone knows from newspaper headlines, battery cars are dangerous. They can go up in flames. Yes, this is true, but the perception is distorted. In Germany alone, roughly 30,000 combustion vehicles go up in flames every year. Whenever you drive on the Autobahn, you see that black spot on the emergency lane. This is where a car went up in flames, but no one worries about that too much because it's known, you're familiar with that. But in electromobility, it's new. So it has to be addressed. How do you address that? There are strict requirements how to document the production process of a battery. You have to document serial numbers of each individual part, of each cell that goes into a battery. You have to document the processes of assembly. You have to document what screw was, fixed with what torque, what angle, in what sequence, and you need to document that and collect all these data so you can prove that the battery was built right because of these safety and responsibility topics. Speed is a necessity because now things have to happen more quickly. When a customer wants a line, he doesn't want to wait 3 or 4 years until that line is available for production. This needs to happen much quicker. So you have to come up with new technologies, more flexible processes, etc. And last not least, in that context, Industry 4.0, so the digitalization of the data that happen or that are collected in the production process help a lot for security, but also to speed up deployment of a line. You can already do a virtual commissioning, in the digital world without having the real hardware available yet. You can have a digital twin of a battery, so you have a virtual copy of the battery for documentation and maybe troubleshooting purposes. So Industry 4.0 plays also a significant role to tackle these new challenges that come with e-mobility. So I've started out with decarbonization, changing players, changing rules, and ended up with how does this translate into changed requirements and possibilities and necessities in the production world. And very happy today to announce that we have a world premiere today showing you a video of the real production of a recently deployed line manufacturing batteries for commercial vehicles with our customer Webasto. This line is obviously specific for that purpose and that customer, but it's a good example of the concepts that are used and that are key ingredients for the considerations of building lines for different customers and for different applications and different requirements. And when you look at the video, you will hopefully remember a couple of things I mentioned in this call and recognize that again and see how this translates into a functional real line. So please enjoy the video, and should you have any questions or interest to enter further discussions, please don't hesitate to reach out. You can find us at KUKA.com. I thank you very much for your attention and wish you a lot of fun with looking at the video of the flexible battery production line with Webasto. Thank you, have a nice day.
Since 2019, we produce for a European bus manufacturer battery systems. In combination, we produce on our multi-product line our own developed CV. This commercial vehicle standard battery pack, what is a plug-and-play system for our customers, can be scaled in a mass production on our assembly line. On the multi-product line, we can produce up to 40,000 packs per year.
Batteries are subject to high safety standards and requirements. For the production, this implies that a great focus must be given to the qualification of processes, monitoring of the processes, to collecting the data that are relevant for each and every part that go into the production, and finally to the collection, to the consolidation, and to the secure storage of all these data for future reference. Battery production is a relatively new technology. This implies that product and processes, but also production volumes and production variety are subject to rapid evolution. For the line again, this means that flexibility and variability are a key ingredient which needs to be considered in all the concepts used right from the beginning.
The big task for Webasto was to create and design a multi-product line with the highest degree on flexibility. This high flexibility should allow us to scale products and adapt products with different size and different specification from our customers.
KUKA strives to improve production concepts over time. So occasionally we develop new visionary concepts, such as the matrix concept. The matrix concept has various aspects. Some of them we have integrated and adopted into the Webasto battery line. One of these new concepts is the decoupling of individual modular assembly stations. We achieve this by using automated guided vehicles called HGVs. It makes it very easy to add capacity by adding new vehicles and to reconfigure a line by simply adjusting the path the vehicle is following. A second concept that we have adopted is what we call the kiosk concept. So at the beginning of the line, there is a centralized commissioning of all the little pieces that go into a battery. This basket of parts travels with the product through the production line, and this way it's possible to significantly optimize and reduce cost for the logistics processes used in this line.
For the first implementation of our multi-product line, we checked the market of line integrators very carefully. Key success factors for us have been delivery time, line concept and robustness. It was crucial for us to work with a supplier with a high experience in this business area. The experience and the local footprint from KUKA was finally an argument for the decision, as well as the ability to work very close with us together. Because this was our first battery project, it was very important to work from the beginning in the area of technologies as well as on the area of processes close together.
Industrial intelligence.